How technology influences the interpretation and valuation of communication through rocks and minerals. Instead of just physical materials beneath our feet, rocks and minerals are silent storytellers of Earth's history. They hold records of ancient environment, biological evolution, and planetary changes. Therefore, as humans, we are always trying to track the view of ancient Earth and understand their message with curiosity, or create tools to decode them. As with each technological advancement, our ability to interpret the complex language of rocks and minerals has evolved. In this video, we'll explore how technology enhances our understanding of these natural elements, from their formation and classification to their practical application and environmental significance. What are rocks and minerals, and how do they form? To interpret rocks and minerals, we must first understand what they are. According to Oxford Dictionary, minerals are valuable or useful chemical substances that form naturally in the ground. In details, they could be interpreted as inorganic solids that naturally occur with a specific chemical composition and crystalline structure. Additionally, rocks are physical formation of one or more minerals. They clip together and classify into main three categories based on their formation: igneous, sedimentary, and metamorphic. Igneous rocks from cool magma or lava, sedimentary rock from piled up particles, and metamorphic rock develops when existing rocks are alternated by heat and pressure. These varieties of structure, textures, and compositions of rocks and minerals are created by nature, and they represent Earth's long and dynamic history. To access the information, making it visible to the human eye, we need the right tool to preserve the information. So how have humans tested and explored through time to understand these hidden messages? How have humans explored rocks? During early explorations of rocks and minerals, direct observation and hands-on tools were significant, such as hammers, notebooks, and simple microscopes. However, as the scope of geology expanded, more powerful tools were needed. With the development of technology such as X-ray diffraction, scanning electron microscopy, and remote sensing, geologists can now examine the mineral structure and composition of rocks at an unprecedented scale, including the investigation of technology application into clay mixtures joint research of rock samples from Redaclar, Spain, representing a significant contribution to understanding and prospecting of interlayered clays. Additionally, tools like geographic information systems have helped geologists to study geological patterns across a large range of regions with enhanced precision. Furthermore, it helps with better research into public health affected by geological reasons. Satellite-based hyperspectral imaging and geospatial data collection are further examples of how modern geology is no longer confined to what can be seen with bare eyes. As our ability to explore has expanded, so too has humans' understanding towards rocks in different aspects such as economically, socially, and technologically. The evolving value of rocks through time. The value of rocks and minerals has evolved through human history in the direction of technological and cultural needs. During the ancient era, rocks were mostly only used for tools and weapons. Gradually, humans began to value some specific minerals for their uniqueness and symbolic power, which includes gold, turquoise, crystals, etc. With the beginning of Industrial Revolution, coal, iron, and limestone became a turning point, central to urbanization and mechanization. Adding to that, nowadays, a new wave of technological dependency has shifted the spotlight to minerals like lithium, cobalt, and rare earth elements due to the fact that they are essential components of new technological developments such as electric vehicles, batteries, and digital devices. These shifts in value are closely connected to human civilization and technological progress. However, rocks and minerals do not just support our technological systems, but are also deeply embedded with them. The role of rocks and minerals in modern technology. Many of the materials that we rely on in high technological industries have geological origins. Silicons, derived from quartz, is the foundation of modern computing and digital development. Tantalum, niobium, and graphite are found in mobile phones, electric car batteries, and medical imaging equipment. On top of that, the interesting thing is technology does not just consume geological resources. It also helps us to find and analyze them. Machine learning and artificial intelligence are increasingly used to classify minerals and complex geographical environments based on large datasets, improving accuracy and reducing uncertainty and challenges during the research. Despite that, rocks and minerals are not only tools to develop the present and the future, they are also windows that allow people to peek into the past. Fossils and environmental interpretations. A great example of exploration with natural history would be sedimentary rocks, which acts as time capsules. Due to the formation of piled-up particles, most fossils are found in this type of rock, which remains ancient organisms that tell us about evolutionary history, climate change, and mass extinctions. These hidden messages are now being studied and analyzed with technologies such as CT scanning, 3D modeling, and digital stratigraphy. Furthermore, isotopic analysis and fossil mapping also help scientists to reconstruct extinct ecosystems and better understand how Earth has changed and how it will change in the future. These discoveries are important for paleontology as well as helping scientists to predict environmental futures. However, as the need for geological materials continues increasing, people need to manage them more responsibly. Managing rocks and minerals with technology. Nowadays, rapid technological expansion raises important questions about sustainability, as the demands for rocks and minerals is growing, including ecological disturbance, instability of soil and rock masses, landscape degradation, and so on. Fortunately, humans are starting to realize this problem and trying to reduce the environmental damage. Developments such as remote sensing, drone-based surveying, and automated extraction have contributed to help reduce the environmental impact of mining by improving accuracy and minimizing unnecessary waste. Moreover, innovations in urban mining can extract valuable elements from electronic waste. This method helps to reduce our dependency on newly mined resources. These technologies support us to understand and use rocks and minerals, as well as learning how to use them responsibly and protect the environment. Rocks and minerals are more than inorganic solids. They are records of time, memory, and transformation. Through them, Earth communicates its history. As technological advances, our ability to decode this geological language improves. From microscopes to drone-based surveying, from data modes to artificial intelligence. Each innovation acts as a translator that helps us to understand the past, navigating the present, and plan for the future. Furthermore, these developments transform our role from passive observers to active interpreters, allowing us to listen to the Earth's silent stories and perhaps write our own more responsibly.